Today I'm going to be doing examples on the integrals of trig substitution with values associated with asecant theta. Alright, so what is the indefinite integral of 1 divided by the square root of x squared minus 16 dx? So when you start off with a problem, when you start with these type of problems, you want to know what type of trig substitution are you going to be dealing with. As you can see, we have a positive x value and we have a negative a squared value. So let's try to see um, which trig substitution formula we're going to use. Out of these, the only ones that has a positive x squared and negative a squared is a secant theta. So we're going to use a secant theta to solve this problem. So the next step is to get our dx and our x squared. So we know that x is equal to a secant theta. So let's try to get the dx and x squared. So x is equal to a secant theta. A squared is equal to 16. Square root of 16 is 4. So that means x is equal to 4 secant theta. X squared is the square root of this. So this is going to be 16 secant squared theta. Dx is the derivative. So the derivative is going to be 4 times secant theta times tangent theta d theta. I think d theta is over here. That's for integrals, so that's my mistake. All right. Now let's plug in the information. We're gonna plug in our x squared over here, and we're gonna plug in our dx. We plugged in our dx. We plugged in our x squared, and now we're gonna try to simplify this. I like to just focus on one thing only, so I'm gonna focus strictly on what's ever in the square root. So the first thing I'm going to do is I am going to take out the 16 from secant squared and regular 16, number 16, and make it 16 times the parentheses square root theta minus 1. And then what I'm going to do is I can rewrite secant squared theta minus 1 as being tan squared theta, and I'm going to do that. Then I'm going to take the square root of whatever's in the square root. So then I'm going to get 4 tan theta. Now I'm just going to try to cross stuff out. I can cross the 4 out. I can cross the tan theta out. And now I'm only left with what is the integral of secant theta d theta. So this is one of the few things in calculus 2 you just have to memorize. The integral of the integral of secant theta is simply just ln of secant theta plus tan theta. That's just something to memorize. So once again, the integral of secant theta, or secant x, whatever, is going to be ln of secant theta plus tan theta plus c. But remember, we can't leave stuff in theta because we start off with x, so we have to change theta to x. And we change theta to x using x is equal to 4 secant theta. So we arrange that and we make x divided by 4 is equal to secant theta, and we draw a triangle. So for secant, we know that it's going to be the opposite of cosine, so it's going to be x is going to be the hypotenuse, and a is going to be the denominator, so just 4. So we just put our values in the triangle. X is our hypotenuse, our a is our 4. We use Pythagorean theorem, we solve for the opposite side, and we get the opposite side is equal to x squared minus 16. Now what are we going to do? We're going to plug our values in. So we have ln is the ln parentheses secant theta plus tan theta plus c is our answer. So we're just going to plug in we're going to plug the information in. So secant theta is hypotenuse over adjacent plus tangent theta, which is opposite over adjacent, and our hypotenuse is going to be x, so we plug x in. Our adjacent is going to be 4, so we plug 4 in, and our opposite side is going to be x squared minus 16. So we plug that in, and there's your answer. That is how you would solve for an a secant theta problem. All right, thank you for watching. Please like, comment, subscribe, and have a great day.